Okay, I'm going to demo a fix for checking replication lag in logical replicas so that we can use that for our PG14 upgrade. I worked on this solution with Matt, and we came up with a query which hopefully works for all the kinds of replicas we will need to figure out whether or not their lag is safe to use them as replica. The architecture I have set up locally is we have one primary Postgres database, and with that primary Postgres database, there's one physical replica, which these are all numbered 1, 2, 3, and 4. The third one is the logical replica. So that is just a logical replica direct from the primary. And then 4 is what we call logical physical replica, which is a physical replica of this logical replica number 3. So that's kind of how the architecture will work in production. In production, we'll really only have the physical replica and the logical physical replica in our replica pool, because we don't tend to put anything that thinks it's a primary or leader in the replica pool, but this query works with all 4 of them correctly. So I will demo that now. The examples, we want to demo it with showing what happens when I write something to the notes table. I write to the notes table, and then I get a new LSN that corresponds to that write. I'll set here the LSN in Ruby code. So this method now we care about is the caught up method to see if our replicas or primary have caught up with that. So we can first check, is the primary caught up? That LSN, it says yes, it is, and that's the query it spits out. We can then check, is the replica caught up? Physical replica caught up? That's also true. Is the logical replica caught up? It is. And is the logical physical replica caught up? They're all caught up. That's as expected. Now, we can pause replication on number 2, which is the physical replica. So over here in my windows, number 1 is primary physical replica, logical replica, and logical physical replica. So 1 through 4 from the top. Now I can pause replication here on the physical replica number 2 and see again, is the primary caught up? It always is, so it should be. Is the physical replica caught up? It is. That's because I haven't written. Okay, now I will actually do another write to make sure it doesn't catch up. So that's my new LSN. And I'll set LSN to be equal to that and do that again. Primary, is it caught up? It is. Physical replica, is it caught up? It's not, which is good. That's expected because it's paused. Is the logical replica caught up? It is. Is the logical physical replica caught up? It also is. That's also as expected because we didn't pause replication for the logical pathway. Now I will resume this one and see now, is the physical replica caught up? It is, so it caught up after I resumed it. Okay, same experiment for logical replica. We will pause the logical replication, which is done by executing alter subscription disable. I think I just did that twice, but it shouldn't matter. And now we do another write again, and we get a new LSN. So we write. Logical replication over here is saying that it's not going to apply it because it's disabled. Now we set the LSN over here. And again, we start with primary caught up. It is. Physical should be caught up as well. Physical replica caught up. It is. Now logical, we should expect it's not caught up. And it's not. And the logical physical, since that follows the logical, it will also not be caught up. Similarly. Okay, so we can now unpause that and double check that logical replica has caught up again, and logical physical replica has caught up again, and the logs are showing that it started and caught up again. So the next experiment is to pause logical physical replica, which is the 4th one. So we go down here and we just pause that. Since this is physical replication from the logical replica, we use the same pause function to pause it. And once we do that, we can write again, notes, get a new LSN here. And in the logs down here, we can also see the pausing is causing it not to replay the walls. That's good. And I'll use my new LSN, A0, and then I will check primary. Is it caught up? Yes, it always is. Physical replica. Physical replica, is it caught up? It should be. It is. logical replica, it should also be caught up because that one's not paused, but the logical physical replica won't be caught up. Excellent. So that's as expected. And then when we resume it, we find it should catch up straight away, and it catches up straight away. So just to break down the query change, what we had before didn't properly account for logical replicas. So the way we've decided to account for that is with this case statement. Basically, this case statement here corresponds to, tell me what is the LSN of this database in the context of what it's replicated from the original primary. So we don't, or in the case of a logical replica, we don't want to know its exact LSN in its context of its database because that's not comparable to the primary. So the way we do that, the first part of the case statement corresponds to basically saying, am I part of logical replication? If we have any row in this PG show replication origin statuses table, that means we're part of logical replication, and therefore we need to use remote LSN from that view. So if we're in here, this corresponds to both the logical replica and the physical logical replica, and from what we've seen, this works for both cases. Then here we have in recovery. This case corresponds to being a physical replica and not a physical replica of the kind that is also a logical replica. So this corresponds to physical replica 2 in our current architecture. In the case of a physical replica, we want PG last will replay LSN. That logic we already had before. And then finally, if we are not either of those, that means we are the primary, and we just use the current wall insert LSN as this value. This case part of the case statement is kind of redundant because it's trying to check the replication lag since some other location and the primary can never really be lagging behind. But in any case, this just means we can use this query for any replica. And as the architecture I have set up here locally, I set all the primaries as replicas as well to confirm that it does work with all of them. The other small change we made is that we actually use this replication lag size method in caught up. So replication lag size, there was previously 2 queries that were very similar in replication lag size and in the def caught up method. Now they just use the same code path for the same SQL query. And the idea is basically replication lag size. If you ask for it without an argument, you're saying, what is the replication to the current primary write location, which we look up from the real primary that we have a connection to. And then if you pass in an argument, you can pass any LSN into it and say, are you up to date with this specific LSN, which is used by the caught up method, which is used in the case of stickiness in Sidekick and rack middleware to determine if a replica has caught up to a specific location when a previous write occurred. So this theoretically should solve both problems. The replication lag size is used in a periodic check to see if hosts are online, and this works here, but it's harder to simulate that actually disconnecting because that becoming offline because you need to create a considerable amount of lag. So that is it for this video. And I will try to demonstrate what would happen if I could get one of or all of these hosts offline. So let's see if I can pause physical. Well, actually, in order to get them offline, one also needs to make sure the replication lag time is less than some threshold. And that's an exact timestamp based thing, which is based on max replication log time, which defaults to lag time, max replication lag time, which defaults to 30 seconds. And the max replication difference there defaults to 16 megabytes, I believe. Actually, I should look that up in, that's just the documentation. Max, in the documentation, 60 seconds, 8 megabytes according to that. Well, in any case, let's try to trigger both thresholds, but we'll have to wait a minute. So let's try to pause the ones we care about, physical replica and the other physical, logical physical replica. Pause both of those. They will not be replicating anything now. So what I need to do is wait a minute, and in that same minute, I need to do at least 8 megabytes worth of writes. So, and hopefully I will start to see in these logs, it should start telling me the numbers are actually slightly different, but this number 2 and this number 4 corresponds to Postgres replica and Postgres replica 4 in those logs. So let's try to do some writes. Maybe well, we could go node dot first dot update node and put a very long string in there. Let's see how that goes. 1,000 times. No. 1,000 times. Do that. Okay. That'll start to do some writes. After that's done, I can take one of my replicas like this one and see how far it thinks it's behind in terms of lag time and the replication lag size. So my physical replication lag size has become 247,000, 248,000. So if that's 8 megabytes, I think we need to get that up to 8 million, but it is going up. So maybe I haven't done enough writes anyway, but well, probably haven't with 1,000, and that was a pretty small note. So, but I can at least see that's going up. Let's try to check the replication lag time. See. So I think we're already over the 1 minute since I paused that. So let's make bigger notes. And probably just 1,000 times to do that again. And copy the same syntactically incorrect code and get the same result. All right, my logs here are still saying everything's online, so I haven't been able to kick anything out yet. While that's going, I will just confirm, well, actually I can look at this value load balancer configuration match replication difference as well to make sure the exact number that is. But where is my lag size now? 291,000. So interestingly, that is not very much, though it keeps going up. The replication lag size that, so if I wanted to check what my threshold was, I should have, I'll be that. So my threshold is 8 million. So 8 megabytes, and my lag size is currently 310,000. So that is not going fast enough. What happens? Let's see if I can create like this. Issuable, notable. Rollback transaction, rollback. What happened? Does not exceed nodes limit. Record invalidated. Okay. Maybe not the best approach, but maybe go with these long notes and just create more of them. Let's see, while that's running, I can probably get my physical replica. Well, I can also see the replication lag size from the perspective of look at my logs. Nothing has gone offline yet. Replication lag size is this query. And if I take this query and take what my primary thinks is currently going on, Actually, maybe I can write from Postgres. I might be able to get that 8 meg of writes done quicker. But that's what that thinks it is. Then what I care about is the diff to that from my physical replica at 500,000. That is not quick enough. Okay. Probably compresses very well that notes that I'm creating, and maybe that's why it's not enough data. Let's see. I can quickly generate a lot of wall. Series. Okay. Just create a table for the purpose of testing. All that actually messes up logical replication. So better not create a table. Better just pick a simple table that I'm familiar with. So look, shards. Fill that out with a lot of data. So insert into built shards, generate series one. Frozen up on me. Do 1,000,000. So that will be the ID and the index base URL. Doesn't matter. They're all not null, so better put. And then now and now. And I think that will insert me 1,000,000 things, but let's just start with 10 to confirm. Oh, I got something wrong there. Insert into that, generate series. Select. There we go this time for sure. Doesn't like that because ID one already exists, but I did generate series for that. So actually, maybe I just need to start with a bigger number. So if I go to that, that's 10 of them starting at 1,000, and we have a unique constraint on everything. So that really makes that less fun. All right, generate random string. No, that won't work. I need generate a series of random strings. Postgres. Well, I don't know if random text will actually work, but let's try. Pause. I think that'll still be. Oh no, that lets me do that. Okay, so if I just start at this number and then go to a big number that will give me, that's going to give me about 1 million of those. Insert 1 million rows there. And then where are we at over here? 500,000 behind? No, I need the new LSN. I get the new LSN. I work out that I should be much further than that behind. Oh. Put that in the wrong thing. Okay. Well, that puts me, okay, 436 megabytes behind. So yeah, I'm gonna stop whatever that was doing and check physical replication side. Yeah, that's big. And is it, have we started logging that it's offline? Offline, yes. Physical replica 4, which was the physical, logical physical, and PostgreSQL replica, which was our physical replica, have gone offline. The other two are online. So that shows that check is working as well. That is all the behavior we need to test, I think, for this. Alrighty.